Afternoon, everybody. My name is Andrew Elwood. I'm from the Staffordshire Alliance Infrastructure Project. I'm just going to tell you about a pilot scheme that we've run with Jim called the Intermediary scheme. So it involves the employment of John, and I'll come to that in due course. So, first of all, Staffordshire Alliance is a construction project. We're not a company, we're actually a pure alliance of tier 1 contractors. We're building on the west coast of Manhattan at the moment. And as the Pure Alliance, first in the UK, we're setting out a different stall for innovation. So we're aiming to develop and implement new technologies within the rail sector. We're not developing them personally, we're migrating them in. So we're looking to tier 2 and 3 of the supply chain, and we're looking to adjacent sectors such as highways, aerospace, and so on. So the way we do this is we need to identify the challenges. I'm just going to give a note to Juice from Mobilio. This is exactly in the same vein as what you talked about this morning. We really do it in real life. So the way that we do this is that we try to use a systematic approach of summarising the challenge on a page. So various questions asked about the size of the price, when it needs to be implemented, kind of obvious things really, but we take the time to really enunciate it. So one of the ones that we identified early on was that we would need to do an activity a couple of times called track slewing. This is when you push a railway track sideways in its most similar form. So this is what it looks like. You can imagine the blue track at the top is what you've built with your highly efficient track laying machine, and the green track at the bottom is the existing railway. The way that you're going to join those is you're going to push them to form the orange piece of track. This is exactly as primitive as it sounds. So there are lots of ways to do that. The way we do it at the moment is we push it with a bigger, but there are various other bits of kit that you can hire. These are called pens and lambs, panel grabbing machines, rail manipulators, the real lathe. And this is called a slewing machine. So there's all these kind of bits of technology out there, but they've all got various kind of sales pitches, but none of them really what I want. The real way is the way we do it. Manual methods would be the way that we do a lot of our track slewing. So what I really want is something that gives me very high quality output. I don't need to do a lot of tampering to it after it's complete, but I want it to be as low a cost as the manual method. I don't want it to be a very expensive higher piece. So this doesn't exist at the moment, and this is where we need to develop this problem further. So all we've done so far is really, work out what our real challenge is. So I was very fortunate to be able to offer this invitation, if you like, to Jim's Innovation Intermediary scheme. So we're looking to have somebody get involved and really take this one step further from the challenge into what might a solution look like. So I'd just like to introduce you to my colleague, Jonas.
So Systematic Innovation were invited to compete in a competition to win the right to take part in this project. We obviously were the winner for this particular project. And after an initial kick-off meeting, I attended the Staffordshire Alliance site, where I had a meeting with site personnel. We managed to fill 6 pages of A3 paper with sketches and annotations and important information about the process. I was also able to sort of go through and highlight what we anticipate an innovative project to be and the elements that make it up. This is the go-to model we use for explaining innovation to our clients and to people that we meet. It's quite simple really. If you don't hit the bullseye, you fail. And the 3 critical components are having a very good technical solution. If you don't have a technical solution, you don't have a solution, but unfortunately, more often than not, in the innovation industry, we get a brilliant technical solution to the wrong problem. We create a solution that people out in the field won't use, or we develop a solution that our organisation just doesn't have the capability of ever using or ever implementing. We also follow another model where we take specific issues of the problem, we really understand it, hence the 6 pages of A3. We then reframe it as a general problem. Once we have found this general problem, it gives us the chance to utilise global knowledge from many industries, because someone somewhere has already solved your problem, or a problem very similar to what you have. It is then a question of refining that solution using your specific industry knowledge to create a specific solution. One of the next stages is to actually look at the functionalities of the elements of the problem. Now, I won't go through this in too much detail, but we have JCBs. They're used to push the rail, which loads the ballast, which creates friction. Once you look and examine the problem at its elemental level, this allows you to generalise the problem. So what we were asked for was a quicker way to move the track, but what was stopping us was the track getting stuck in the ballast and the frictional forces that could potentially lead us to do damage to that track when we're trying to move it. So the real problem is to reduce the friction between the ballast and the sleeve. And in our problem-solving toolkit, this can be further simplified to speed versus force or torque. So once we know it's a problem of speed versus force or torque, we can plug it into our system, and it says that people from a range of industries across the world use those 5 specific solutions, or those types of solutions. Now, I won't go into too much detail because we have a limited amount of time, but the key insights from those 5 elemental principles were to replace continuous actions with pulsing actions, to turn flat surfaces into curves, and to move things to fixed and vice versa. So knowing this, I created my first thoughts in a sketch. This sketch is of an attachment for a JCB road rail. We then presented this and the initial findings to the team at Staffordshire Airlines. Very crude, I know, but we had a good session where they gave us all the, oh, what about this? It'll never work because of that. What we like to call yes but problems. It was actually quite dark. A lot of the reasons that they gave for something not working, we had to go back to the drawing board a second time and run their comments through the tools and the problem-solving equations again. Like I said, we believe that someone has already solved the problem. Whilst this isn't the solution, what is in this picture makes up a lot of what a viable solution would look like. The elements that are in this machine could be used to create our solution. So I went off and I found people in the industry that make equipment like this, and I got their insights and their input into what our solution could look like. And this next slide is what we came up with. Now this is a rendering done by David Thompson, and this is the concept of an attachment to the JCB that acts like the lifting beam, the device that was in the previous picture, but also like a thimble. And this is what this machine does. It is a hybrid piece of equipment that's never been built before that will allow us to both lift and manoeuvre the railway at the same time. And because we can lift and move and position on the JCB, we're able to move, and it will be a lot faster than the conventional method. And back to you.
So I've got a plot spoiler for you then. I'm obviously going to ruin Ben's presentation because we can't. So if you don't want to know the scores, look away now. So it worked quite well, employing SI to kind of develop the concept through to something that we might be able to apply for funding for. And that's exactly what we've done. So we applied to Network Rail for the seed corn funding scheme. This is intentionally to bring products through from concept into something like market readiness. It's a stage gate process, so you keep going back and asking for more money to further develop the product. So we worked with an engineering company to do this, and we've been getting grant funding up to Gate 2 at the moment. So, that brings me to where we are now. I'm looking for an engineering company to develop this concept with funding through to the point of application. And at the moment, I'm looking to trial this concept solution on my scheme in October this year and April next year. So the money's there and the opportunity's there. Thanks a lot.
Thank you very much, James. It's great to hear from the sharp end on how you're actually going about solving problems. We think innovation intermediaries is quite a key tool in the weaponry that the rail industry can deploy to find solutions. We heard at our second Unlocking Innovation workshop way back in Coventry how the automotive sector does it. And IXC, who are here today, do quite a lot of work in that area. So I think innovation intermediary is quite an opportunity for the rail sector, and it can work using the model that we've just heard about. There's another trial that's just been completed with London Underground. We'll be presenting a case study on that in the future. But there is a guide that has been produced, a very short guide on the do's and don'ts of how to work with innovation intermediaries, and we'll be making that available to you shortly. So thank you very much.